All right, so we are just going to review how to use angles of elevation and depression to help you solve problems when there are two lengths that you're going to have to deal with. So for this first one, from the top of a canyon, the angle of depression to the far side of the river is 52 degrees. The angle of depression to the near side of the river is 81 degrees. And the depth of the canyon is 132 meters. We want to find the width of the river at the bottom of the canyon and rounding to the nearest tenth of a meter. So first, in order to draw this, we know we have a canyon. And we know we have a little river at the bottom. So let's add some water. Water. Okay, there's my river. So with this, we know that our angle of depression to the far side of the river is 52 degrees. So remember, angles of depression and elevation have to have a horizontal line. So to go to the far side, we'd be there. Let me redraw that. Boop. And then to the near side, we'd be there. So I'm going to be looking at this green triangle that I just drew. Fix the side of my canyon so it's a little bit straighter. My whole canyon went away. It's okay, we'll work with it. Okay, so we know that the canyon is 132 meters. So we're going to have 132 meters. And then angle of depression is 52 to the far side. So my far side is the one that is closest to that horizontal line I drew. So that is 52 degrees. So because that angle is 52, because of alternate interior angles, remember I have this Z right here. So I know that this angle down here is also 52 degrees. And then for the other one, it is all the way over, so that is going to be 81 degrees. And since that big angle is 81, then I know that this one is also 81 degrees. So we want to know what is the length of the width of the river at the bottom. So I'm going to set this up as X, and I'm going to say this full length is Y. And I'm going to find each length and then just subtract them at the end. So starting off, we'll start with the 81. We would have, we have our opposite and our adjacent. So that tells me that I'm going to be using tangent because tangent uses opposite and adjacent. So tangent of 81 equals 132 over X. So then we have to multiply both sides by X. And then we divide by the tangent of 81. So then X equals, pulling out the handy dandy calculator, 132 divided by tangent of 81 is 20.90 or 91. It's 906, so we round up to 91. And then to find my full length, I'm going to do tangent of 52. Because we're moving back. So then the tangent of 52, my opposite is still 132, and now my adjacent is Y. And remember, Y is the full length, or the full side. Okay, you don't want to forget to subtract. So we do the exact same thing, multiply both sides by Y. So Y times tangent 52 equals 132, and then we divide by tangent 52. So I have Y equals 132 divided by tangent of 52 is 103.13, and that one also rounded up. So now I know that this full length from this to this, that full length is 103. And then I'll do the blue. The X is just that one little bit. So we notice we still have that tail. So to do that, we just subtract 103.13 minus 20.91 minus 0.91. And I get 82.22. So because we want nearest meter, that would be 82 meters. Okay. So when you're doing this, probably one of the easier ways for most is to look for the full length and then the little length, because it's like the problems where you had to find the area of a shaded figure and find the area of the big one, find the area of the small one. Same thing.